Okay, so let's now go ahead and look at some more questions out of 2, 3, and 4. So 2.3 and 2.4. Those were, again, combined together. The textbook separates them out, but I combine them together. And we're going to look at question 3. And this one has fractions with parentheses. Five times 20 x minus 15. Okay, so when I see this type of question, first thing I notice is I have parentheses, right? So those have to be dealt with first. Before anything else is done, we have to deal with the parentheses. Then we can clear the fractions. But before we even do that, we have to deal with the parentheses. So that 1/4 gets distributed through. And this 1/5 gets distributed through. If you struggle with these fractions, write them over to the side. So we've got 1/4, and we're going to multiply that by 12x. So we'll write that as a 12x over 1, right? Now, we are multiplying. When we multiply, what can we do with our fractions? Remember, we can cross cancel, can't we? So that 12 can cancel with that 4, and that's going to leave you with a 3 and a 1 down below. 3 times 1, that gives you a 3, and don't forget your x there. Right, so 12 divided by 4, that leaves you with that 3x. Same thing for the 16. We've got 1 over 4. We're going to multiply that by a minus 16 over 1. Those can cancel, right? And that leaves you with a minus 4 and a 1. 1 times a minus 4, that's a minus 4. Is everyone okay with that, right? Because 16 divided by 4, well, that's a 4. Don't forget your sign is negative, so that comes down. Right-hand side, similar procedure. 1/5 times that 20x over 1. The 20 and the 5 cancel out, and that leaves you with a 4 and a 1. And so that comes out to be a 4x. Next, 1/5 times that negative 15 over 1. Those cancel. That leaves you with a negative 3 and a 1. So that comes out to be a negative 3, doesn't it? Is everyone okay with what I did? Parentheses have to be dealt with first. So they're done. Now what do we need to do? Now we need to get the x's on the left-hand side. So what would I do next? Can someone tell me? Yep, subtract off that 4x. And that leaves you with 3 minus 4. That leaves you with a minus 1x, or just a minus x. And then we've got our minus 4. And then on the right-hand side, we have the minus 3. Okay. How do we finish it? We've got 2 more steps left. Okay. Yep, I would add that 4, right? That way that the x stays on the left. Numbers go to the right. So that leaves you then with a minus x equals 3 that's negative plus 4. That leaves you with a positive 1, doesn't it? How do we finish it? Are we done yet? Not quite. We've got one more step. What do we need to do? Okay, divide by a negative 1. And that now finishes it, because that leaves me with x equaling a negative 1, doesn't it? Sure, sure. Yep. We can keep doing these until we get them down. We have to know how to solve these. So we can add more if we need to. We'll add 6 to the list also. You're welcome. Because we can't really do the applications and understand those completely until we get these down. So we have to know how to solve them. Very, very important. Now that was question 3. Right, so we will now look at question 6.
Could you do 5 first?
Yep, we can do 5 first as well. Okay, question 5. Very similar to question 3. So we've got 1/5 times 10x minus 15 with parentheses. On the right-hand side, we have 1/3 times 9x minus 6. Parentheses are going to go first, so those have to be dealt with first. Now, on the last one, we wrote out every single fraction. Let's see if we can do these mentally now. We could write it out like we did on the last one, but let's try and see if we can do these mentally. Okay. 10 times 1 is 10, right? And 10 divided by 5 makes it a 2. So that's going to make that a 2x there, right? So we divided, or multiplied and divided. What about the next one? Negative 15 times 1, that's negative 15. And negative 15 divided by 5 leaves you with a negative what? 3. And you can write it out if you need to. Just like we did on the last one, you can write them out. But if you are comfortable doing them mentally, like this one I think you should be able to, and you can just write down each piece.
If you have some number that the 5 won't divide into,
Right, yeah, then it would leave a fraction.
like 21x minus 15.
Right, then it would be, if that would have been like a 21x here, that would leave you with a 21 over x over 5. Okay, if that would have been a 20. This one doesn't, and these don't.
And you have to work it out.
Right, we'd have to work it out. These don't. They get a little more complicated later on, but these are, in this section, are the ones that we can just work through, and they cancel out this way. So yeah, and later on, they'll become a little bit more difficult. Like question 11, I think. Yeah, it has fractions that won't completely go away. But we'll look at that one next here. Okay, but let's go ahead and finish this one out, because I know that those divide. So it's easy enough to do. What about on the right-hand side? 9 divided by 3, that's a 3x. Okay. And negative 6 divided by 3, that's a negative what? 2. Now, all the fractions are gone. What's my next step? Yep, variables go to the left, so the 3x is positive, so we make it negative to move it over. 2x minus 3x, that leaves you with a negative x minus 3. And the right-hand side is now a minus 2. Is that making sense so far? Okay. Yeah, and we'll look at some later on where it doesn't divide through, but these do, right? Because 10 divided by 5, 15 divided by 5, 9 divided by 3, 6 divided by 3. Come out even. So what do we need to do? Finish this. We add what? Add 3. Okay. And that leaves you now with minus x equals 1. Are we finished? Nope. Almost, though. What do we do? Divide by a negative 1. And that now leaves you with x equaling what? Negative 1. And that is going to be my final finished answer. Is everyone okay with that one? And it's very, very important that we understand these, because if we can't solve equations, we're not going to be able to do those applications. So I don't mind working out as many of these as we need to make sure we completely and fully understand the steps. Question 6 is next. I know last time we went over a lot of material, and I did that because you don't really know what you struggle with until you actually do it. And so I wanted to give you a lot of homework so you'd actually know where you struggle at, and so I can see that. So question number 6, we've got 2x plus 4, we've got parentheses, minus 3x, minus 7, and that equals a minus 32, minus 6x. I guarantee students are going to make mistakes if you're not careful with the parentheses. So, what needs to happen with the parentheses? We need to distribute that 4 through, not the 2x, right? Only the 4. A lot of times I see students try to do it all, but only the number in front, directly in front of the parentheses, goes through. So only the 4 does. And now we distribute through. And that leaves us with 2x, and then we've got 4 times a negative 3. That's a minus 12x. 4 times a negative 7. Well, that's a minus 28. Now we can combine. So what can we do on the left-hand side? Well, on the left-hand side, these can go together, can't they? Right? Because they're both x's. So 2x minus 12x, be careful with the signs. That's going to be a minus 10x. Now, what do we do next? We're going to add that 6x over. Be careful with your signs. Minus 10. 10's a larger number, so that's negative. So minus 10 plus 6, that's a minus 4x there. And then we've got our minus 28, and that equals a minus 32. Okay, what's next? Okay, add our 28 to each side. And that leaves you with a minus 4x. And watch your signs here. Is it going to be positive or negative? Negative. Okay. And minus 32 plus 28, that's a minus 4, isn't it? Is everyone okay with that so far? Yep, let me move it up so we can see. So let's talk about what we did. What did we do first? First thing, when I look at any type of problem, is if I see parentheses, those have to be dealt with first. Once the parentheses are dealt with, then, if we need to, we can clear fractions. And then we can start combining like terms. Once those are combined together on each side, then we can move across the equal bar. And then what's my very, very last step? Always the last step is, if needed, you're going to divide. And what are you going to divide both sides by now? Okay, we need to get rid of that negative 4 in front of the x. So I'm going to divide both sides now by that negative 4. That leaves me with x by itself. Negative 4 over negative 4, well, that leaves you then with your 1. So that is my finished answer. And x now equals 1. Sure. Sure, yeah, okay. Yeah, we can look at 8. And 8, you're correct. 8 should be an identity because everything's going to cancel. But let's look at 8.
So would I write just identity?
Yeah. They're the same, right? And I just write the same, so I know they're the same. And then the correct term would be identity, and it would be all real numbers. Okay, but we can go ahead and work it with 8 just so we can see what to do. So that 6 has to be distributed through. And then I always like to circle the negative in front, and that also has to be distributed through. So let's see what we get. 6 times x, that's a 6x. And 6 times 4, that makes it a 24. Now, when we distribute the negative through, that gives you a minus 6x and a minus 24. Now, you are correct, because what's going to happen on the left-hand side? Yep, everything goes, because a 6x and a negative 6x, those can cancel. 24 and a negative 24, those can also cancel. So what are we left with now? 0 equals 0. Now, these are the same, aren't they? If they are the same, then what does that mean it is? It's an identity. And what's my solution set? All real numbers. And so this is what I would want for my answer. Identity, all real numbers, just like that. And I should have boxed that previous one, but now you see that's what I'm wanting to see there. So that was question 8. And we did 5 and 6. 10 is the next one. Now, 10, the fractions aren't all going to go away. So we are going to be left with something. And this is kind of what you were talking about, MJ, with the fraction left over. So on question 10, we've got 1/5 times r plus 6 equals 1/7 times r plus 8. So we'll clear the fraction, or sorry, clear the parentheses first. Now that 1/5 times r, well, that just leaves you with 1/5 r, right? Because nothing cancels out there. Now, on the previous ones, remember when we looked at the previous ones, they went away. Like when we looked at this one, okay? That 10 divided by 5, that left you with the 2, and it went away. But this one, does 6 go into 5 evenly? No. So we're just going to leave this now as, okay, 6 times 1 is a 6. So that's going to be 6 over 5 there. You just put it as a fraction, okay? And if you need to, we can work it out over the side. Because 1/5 times 6 over 1. 6 times 1 is a 6. 5 times 1 is a 5, right? And nothing cancels. What about the next one? On the right-hand side. That's 1/7 r. Okay. And does 8 go into the 7? Nope. So 8 times 1 is an 8 over 7. Okay, so this one, the fractions didn't go away. So now we have to resolve these fractions. And we need a least common denominator. Okay, someone said it, 35, because that's the least common denominator of 5 and 7. And let's take our time. 35 divided by 5. Well, 35 divided by 5 is a 7. Times 1 makes it a 7, r, so we bring the r down with it. Next one, 35 divided by 5, that's a 7, okay? 7 times 6 makes it a 42. Divide, and then we multiply. Next, 35 divided by 7. 35 divided by 7 is a 5, times the 1, that makes it a 5r. 35 divided by 7, that's a 5. Now, 5 times the 8 on the top leaves you with a 40. Divide by the number below, multiply by the number on the top. Okay, now fractions are gone, parentheses are gone, everything's been combined together. So let's move them around. Move that 5r over with subtraction. Positive 7r minus 5r. 7 is bigger. It's positive. So that leaves you with a 2r. And then we've got a plus 42. And that equals 40, doesn't it? What's my next step here going to be? Go ahead and move that 42 over with subtraction. That way it goes to the right. And that leaves me with 2r equaling 40 minus 42. That's a negative 2. And what's my final finish step here? Divide by the 2. And now we've got r equaling a negative 1, isn't it? So that's question 10. Question 11. Fractions again. So these aren't going to cancel, just like 10. 11 is very similar. We've got 2/3 y minus, parentheses, y minus 1/4 equals 1 over 24 times y minus 8. Students tend to make a mistake with this one because they get confused with that 2/3 y in front. All right, that 2/3 y is not going to be distributed through. What is directly in front of the parentheses? Negative. So that is the only part that gets distributed through. Not the 2/3, right? Only part in front is that negative. So that's what goes through. On the other side, we distribute that 1 over 24. So we've got 2/3 y. When we distribute the minus through, that makes it a minus y. Negative and negative makes it a positive 1/4 there. Is everyone okay with that so far? What about on the right-hand side? 1 over 24y is there. What about that 8? Let's see what it does. We've got 1 over 24 times a negative 8 over 1, right? That's what we're doing. We're multiplying. Can I cancel that 8 and that 24? And can that reduce down? Yes. Right, because negative 8 and 24, well, that can reduce down to be a negative 1. And 8 divided by 24 is a 3. So 1 times a negative 1, that's a negative 1. 3 times 1 is a 3. So that's going to come out to be a negative 1/3. Is everyone okay with that? Or you could do it like this. Just multiply across, right? Okay, and if I have a negative 8 over 24, what does negative 8 over 24 reduce down to into? Negative 1/3, right? Yep. Either way you want to do it. You can either write it out and cross cancel like that, or if you don't see it, multiply across the top, multiply across the bottom, and reduce it at the end. But either way, it's going to reduce down to a 1/3. Now let's clear out the fractions. So what do we have for our denominators? We have a 3, a 4, a 24, and another 3. When I look at this, I look at my largest number. What's my largest denominator? 24. Does 24 go into 3? Evenly. Yes. Does 24 go into that 4? It does, doesn't it? Right? Because 24 divided by 4 is 6. So what can I multiply it all by? 24. That'll clear it all out. So when I work with these fractions, the first thing I do is I look at my largest number. And I ask myself, does it go into the other 2? And if it does, then multiply it. And that gets rid of it. Now we start distributing. So let's see what we've got. 24 divided by 3. 8. And 8 times the 2 on the top makes it 16y. 24 times a negative y. It's a minus 24y there. 24 divided by 4. 24 divided by 4 is a 6. 6 times 1 makes it a 6. Equal sign comes down. 24 divided by 24, well, those cancel. And that leaves you then with just the y, doesn't it? 24 divided by 3. 24 divided by 3 is an 8. And 8 times that negative 1, well, that leaves you now with a negative 8, doesn't it? Okay. What's my next step going to be? All right, so the next step, we're not going to move things around yet. What can we do? Always look on the left and the right. Those on the left can go together, can't they? So before anything gets moved over, always make sure you cannot combine. In this case, we can combine because 16 and a minus 24. Well, 16 minus 24, that leaves you with a minus 8y, doesn't it? Now we can start moving with the equal sign, moving across. So let's move that y over. And that's a minus 1y. And you can write it as a minus y, or you can write it as a minus 1y. Doesn't matter. Minus 8. And you can put the 1 there if it helps. Minus 8 minus 1 makes it a minus 9y, doesn't it? Right? Watch your signs there. If it helps, put the 1 there. It's minus 8. Think about, you already owe the bank $8. You take out another $1, you now owe them 9. Right? So it's negative there. And then we've got a plus 6. And that equals our negative 8. And what's my next step? What are we going to do next here? We're going to subtract that 6 from each side. Okay, so that's going to be our next step. When we subtract them over, minus 8, minus 6, that leaves you now with a minus 14. The left-hand side is that minus 9. Okay. And what can we now do? Divide by what? Negative 9. And now we've got negative over negative makes it a positive. And a lot of times they'll come out to be whole numbers, but not always. In some cases, you might have a fraction left over. This one leaves us with a fraction, doesn't it? So is everyone clear how we did that? So what did we do first? Let's review it again. Parentheses went first. Then cleared our fractions using a 24. Then we looked at the left-hand side, and the y's could go together. And that left you with that minus 8y on the left. Then we were very careful when we moved that y over, right? Because if it helps, put the minus 1 in front, because it is a minus 1. And minus 8 minus 1 makes it a minus 9. Then we moved our 6 over with subtraction. Those went together to give you that minus 14. Then we divided by a negative 9. Negative and negative, that made it a what? Positive. Okay, question 14. We've got 2/5 x minus 1/3 x equals 5. So, do we have any parentheses? No. Okay. We need to clear our fractions. What can we multiply everything by? Okay, someone said it. Multiply it all by 15. Make sure it goes to the 5 as well. Right? Make sure it goes there also. So now we divide and multiply again. So 15 divided by 5, that's a 3. 3 times 2 makes it a 6x. 15 divided by 3, that's a 5. Times a minus 1 makes it a minus 5x, doesn't it? Where do students make a mistake at? The most commonly made mistake is right here. 15 times 5. You have to multiply it. 15 times 5, that's your 75, isn't it? Make sure you don't just leave it as a 5. It has to be distributed through. That is the most commonly made mistake. Each and every part gets that 15. Even if it's a whole number, it still gets it. Now we can finish it because these go together, and we now have a single x, and that equals 75. We've got the x by itself, and so now we know that we're finished. Is everyone okay with that? So that one wasn't too bad once we were careful. Again, I have taught algebra for 20 years, and I know where the mistakes are. This is the most common one. That's why I have you draw these arrows out. That way you remember it goes through each and every part. Well, last time we also did some of these out of 2-5. And we'll look at question 5 from your homework, and then we'll come back and we'll try to at least finish up a little bit more of 2-5. So someone asked about that question 2 from your homework out of 2-5. Okay, so how do we handle these applications? We started some of them last time, remember? What we do is we read it first, and we try to see what we're working with, how it all relates together. Now, I like to write things up in words so it's easier to understand before we use variables. So question number 2 is what we're looking at. On August 10th, the Evelyn family received 19 pieces of mail. And that consisted of magazines, bills, letters, and ads. If they received the same number of magazines as letters, 3 more bills than letters, and 5 more ads than bills, how many magazines did they receive? So, what did I notice here first? When I read it, it says the Evelyn family received 19 pieces of mail. So that is a total. So I look for things like that. If I see something has a total, then I know I've got to list out all the different parts that go in it. So we know we have a total of 19 pieces of mail. So we're going to start with that. Now, what are we working with? We've got 4 different types of mail. We have magazines. We've got bills. We've got letters. And we've got ads. And we know that these all go together to give you 19. So whenever we look at an application, that's the first thing I try to do. Figure out where to begin. So first thing I saw was that 19. Okay, what does that 19 represent? Total pieces of mail. What's in the mail? Magazines, bills, letters, ads. Okay, simple enough there. Now, we need to see how they all relate to each other, because our goal is to build an equation with the variable x. And I'm going to try to keep this side on the left. I'm going to try to keep this cleaner than the right. The right can be whatever we need to use. So let's see what we've got. Okay, they received the same number of magazines as letters. So we know the magazines equals the letters, right? They're the same. So that's the first thing we notice. They're the same. So I just wrote them the same. Okay. Then what do we have? Then it says 3 more bills than letters. So the bills are going to be the letters plus 3, right? Is everyone okay with that? You see where that came from? Okay, let's make sure. 3 more bills than letters. So that means that the bills are going to be the letters plus 3. Okay, because 3 more bills than there are letters. And what's the last piece here? 5 more ads than bills. So 5 more ads than bills. So the ads are then going to be the bills plus 5. Okay, is everyone kind of okay with how I got this set up? So we know that letters in the magazines are the same, so that's why they're going to equal each other. We've got 4 parts here. Bills, letters, magazines, ads. 4 different pieces. This is a kind of complicated one. Bills and magazines letters and magazines are the same, so that's why they're equal here. Let's write it up twice so we can see all 4. Now we need to rewrite this with the variable x. I am going to use x to represent the number of letters in magazines because they're the same. Okay, magazines and letters are the same. So magazines, if I can write it right here, magazines, I'm going to use an x. That means the letters are also what? Because they are the same, right? Now we go to the bills. What do we know about the bills? Okay, the bills are the letters plus x. And so what did we define the letters to be? X, right? So what would the bills be with the variable x? That would be x plus 3. Are we okay with that, right? Because letters are x. Okay, the bills are the letters plus 3. So that means my bills are going to be x plus 3. Now, what about the ads? The ads is a little bit more difficult to deal with. The ads. Okay, when we look at the ads, how do the ads relate to the bills here? Ads are going to equal the bills plus what? 5. What are the bills defined to be? With the variable x. Okay, we just said that the bills are what? x plus 3. Okay, that's your bills. And then what are we going to have to add in still? Plus 5. And that makes that now x, when we put them together, plus 8. So now we've got all of our parts. We've got the letters and the magazines are the same. So they're going to be declared the variable x. The bills are the letters plus 3. Letters were x, so that's x plus 3. What about the adds? The adds are the bills plus 5, right? Now, what are the bills? X plus 3, right? What else do we have to add to that? Plus the 5, so that makes it then x plus 8 for my total there. Now we should be able to get our equation and answer the question. Okay, so what do we know? Let's fill it in. It's going to draw arrows here. Magazines. What did we define the magazines to be? X. So that comes down with that. Bills. What did we define the bills to be? Okay. Yep. X plus 3, right? So that goes there. Then we've got letters. What are the letters? Oops, this wants to move here. Letters are X. So that comes down as a plus X. And then finally, we've got our adds. Okay, and what are our adds? Yep, adds are going to be X plus 8. And what does that equal? 19. Is everyone okay with how I built that equation? Right, they just get plugged together. I like to use arrows. Now, once you get good at things, you don't have to do that. We're just learning the basics. So I draw a lot of arrows and things like that with a colored marker so you can see them. Now, what can we do? Next, we need to solve this. How many x's do we have here? If I add them together, I've got 4. Three and 8 makes it 11. So I've got 4x plus 11, and that equals what? 19. Okay, now we've got our equation, right? So now we can finish it. So what do we need to do next? Subtract 11 from each side. And now we have 4x, and that equals 8, it looks like, doesn't it? And what's my last step going to be here? Divide by your 4. And now what do we have x is going to equal? 2, isn't it? Okay, let's find out all 4 of these, and let's see if we get our total to be 19, because they should add up to give you 19. So let's try to get each one of these. Magazines, that's x, and x was 2. Letters. Letters was x, and x was 2. Bills. Bills are x plus 3, and that's 2 plus 3, which is then 5. And finally, the adds are x plus 8, okay, and that's 2 plus 8, and that gives you now the 10. How do we know we did it correctly? How many pieces of mail should they have total? 19. If I add up the magazines, the letters, the bills, and the ads, did they give you 19? Yeah. So we know we did it correctly. Now, what does the question specifically want? Okay. It says specifically how many magazines did they get. So we want the number of magazines. So your answer here would simply be 2 magazines. And that's all we needed to do was 2 magazines here. I like to get all 4. And that way you can look at it and make sure it makes sense. All we needed, though, was the magazine. So we could have actually stopped earlier. Could have stopped up here, but I like to get all 4 just so it makes sense. Oh, which one? Yeah. Let's take a break first, and then we'll come back, and we'll look at question 1. And I don't mind working through these because we need to make sure that we understand how to solve these equations. Very, very important.